Okay, so for this one, okay, trig ratios. We are going to introduce some sine and cosine functions, like which multiple sine and multiple cos times together. So this is what we're going to learn today. So we have a couple of situations we can talk about. The first one is the basic one. So doesn't matter what kind of trig functions. If there's multiple sine and multiple cos times together, we always want to get it back to the first case. So the first case is there's one sine with multiple cos or one cos with multiple sine. Okay, so give examples. So if we have a sine to x times a cosine power 4 of x dx, that's a good form we can use. Or we have 1 cosine to x and like 3 sine to x of dx. Well, not only sine, like I can go 3x and 3x here. So, but they must have the same angle. Okay, they must have the same angle, like with 1 cos many sine or many sine 1 cos. So this is the standard form I need to use substitution. Okay, if I want to use substitution, I need to use this form. So what we will make u becomes is the difficult one, like the more complex one. So in the first case, we will make u to be cosine to x. So we make the complex one becomes u, so du dx equals to minus 2 sine to x, and dx equals to minus 1 over 2 sine to x of dx, du. Okay, so it's exactly the same as what we do before. Why I need a single sine to x is used to cancel with the minus 1 over 2 sine to x. It's going to cancel with that one. So if I have a single sine and many cos, we substitute u to become cos. And then this equation will become cos becomes u, so that's u to the power 4, and 1 minus negative 2 sine to x of du. And we have, well, this one and this one will get cancelled. The sine to x and the sine to x get cancelled. What we left is negative a half of integral of u to the power 4 of du. And that's a minus 1 on 10 u to the power 5 plus c. And that's minus 1 on 10. U is cosine to x, cosine to the power 5 of 2x plus c. Yeah, that's the most basic one. Later on, we'll have like more complex expressions. You won't have a single sine, single cos. You may have 1 minus cos squared or something like that. So what you want to do is you want to leave one sine and all the other expression becomes cosine, or leave one cosine, all the other expression becomes sine. So that's your purpose. If you can manage to make it into that form, you just make the substitution easily from that step. I'm not going to show the next one. The next one will be pretty much the same. Instead, you make sine becomes u. Okay, sine 3x becomes u in that case. And then you do antidiff from that. That's the basic form. So that's how we can solve that. But say we're not going to always have one single sine or one single cos. You may have multiple sine and multiple cos. Okay, so in this case, multiple sine and multiple cos, if the power both greater than 1, we consider the second situation. Okay, if the power, let's say they both greater than 1, we consider this, well, one of them greater than 1 will be fine. In this case, like what I need is both or one of them needs to be odd number. Okay, if they are both even, I can't really use this method. So one of them must be odd number. Okay, so the rule number 1 is if there's only one odd, change the odd. Okay, you just write it down. I'll tell you what that means. The second one is if there are both odd numbers for the power, change the smaller one. Then change the smaller one. I'll tell you what means by change it. So if one of them is odd, we change the odd one definitely. If both odd, we change the smaller one. Okay, we'll let you know why we change the smaller one. It doesn't really matter which one we change if they're both odd, but like change the smaller one will make calculation easier. So give your examples. So if we have sine to the power 4 of 2x and cosine 3 to the power of 2x. Dx, that's one example. And the next one will be sine to the power of 7, okay, go to 3 or 4x and go cosine 7 or 4x. Okay, they're both odd in this case. Okay, don't forget what's the purpose, like when we do rearrangement. We want to get one sine and all the others becomes cos, or one cos, all the other thing becomes sine. So now I need to change, like say, change the odd number. So I will change that one. So how we can change that one? Yeah, I will make it to the front. Cos 3, okay, cos to the power of 3. So we need to get one out. Okay, why I get one out? Because I need one cosine to be singled out and all the other things change to sine. And then how many left is power of 2? So I got 2 left. And then the sine for x will stay the same. Sine to the power of 4 to x stay the same. So that's the first step, we will change it. And the second step, okay, this cos is the one I want to keep. Okay, I want the single cos. Now, like this cos is not good then. Okay, I don't want those cos. It needs to be changed to sine. So how that can be changed to sine? 1 minus sine squared. Good. So we keep one cos here. And then this one becomes minus 1 minus sine squared to x. And then sine to the power of 4x. Okay, question. If that's a power of 4, if that's a power of 4, what we should do to change it to sine? If that's the power of 4, not the power of 2. You will square that. Because of cos, power of 4 is cos 2 and then another power of 2. So power of 2 will change to 1 minus sine power of 2 and then another power of 2 here. So that's why we need to change the odd number. If you take 1 out of the odd number, what you left is only even number. And if the power is even, you can always make a change to sine, like use 1 minus cosine square or 1 minus sine square. So that's why you always need to change the odd one to leave an even number of amount, and then use the the identity, like the Pythagoras identity one, to change it to another, like sine change to cos and cos change to sine. And after that, like I have made the form into the first one, so I will let u become sine to x, and then follow the step, whatever you should do after that. And cos to x will get cancelled later. Sorry? U will make sine. The complex one makes the sine. So you don't touch the single one. The single one's used to cancel with the like the thing, like the d dx thing. Then you change all the rest to become 2. So sine change u. All right. Next one, I want to explain why we change the smaller one. So I have 3 and 7. I can change out of this. So if I change, okay, I go 2 different steps. I change the 3 first. If I change the 3, so that's power of 2. And cosine is power of 7. And then if go for another step, that's 1 minus cosine squared 4x. And cosine 7 4x. But if I change the larger one, I'll have that. So I'll keep this cosine here, but to the power of 6 is to the power of 2, then to the power of 3. So that's 1 minus sine 4x. And then you have another power of 3 here. Do you see why we should change the smaller one? Like, change the smaller one, you don't have a large power there. Like, it's only power of 1 there, but this case is power of 6, then it's power of 2, and then power of 3. So we need a power of 3. Oh, there's a square here. Even when you substitute that into u. So let's say in this case we need to sub cosine becomes u. I'm not going to write a full expression, but just give you a feeling like when we substitute u, like you know that this sine for x should be cancelled after I do the du dx. So after I change to u, that's 1 minus u squared and then u to the power of 7 of du. And there should be some coefficient there, like minus a quarter, I think. You should have some power in the front. So that's after substitution, I will have that expression. But for this one, if I sub that into sine 4x, use sine 4x. So this cosine will get cancelled. I have a 1 over 4 in front. This will become 1 minus u squared to the power of 3 times u to the power of 3 of du. Which one is easy to solve? You don't need to copy this down. Just have a think. Like I have substituted for you. Which one is easy to solve? Left or right? Left. You can easily expand it and then antediff it. But for the right hand side one, you need to get a root like to the power of 3, expand it first, and then times it, and then antediff that. So it's more calculation involved for the second method. Do you get why we changed the smaller one? But it doesn't really matter which one you change. You get the same answer anyway. Okay. Any questions so far? All right. Then we are going to talk about some special ones. So the special one, the first special one is both power is 1. Okay, there's no power greater than 1, so both power is 1. This case we need to, well, we can't really use like substitution. Well, we can use substitution, but like it's not really worth it. So what we should do is use double angle formula. You can use double angle formula. So sine, I write it here, sine 2a equals to 2 sine a cos a. So when I go for antidiff, I can just make sine a cos a becomes a half sine to a, and I can easily antidiff a half sine to a. Yeah, that's the first one. The second one is to deal with sine to the power of n of ax and cosine to the power of m of bx, where m and n are even. So you just antidiff a single sine, single cos, but the power is even. The power is like to the power of 5, or to the power of, to the power of 4, or to the power of 6, or to the power of 2. Normally we do to the power of 2. Okay, so say for antidiff sine squared like x. It looks very easy, but it's actually not that easy to like solve. So what we need to think about is the double angle formula for cosine. So cosine to, that's a. So cosine to a, there are 3 formulas, but 2 is very useful. One is 1 minus 2 sine squared a, and the other one is 2 cos squared a minus 1. I can rearrange those 2 formulas to reduce the power of 2 becomes power of 1 by using the double angle formula. So sine squared a equals to a half 1 minus cosine to a, and cosine squared a is a half 1 plus cosine to a. Okay, so that's the 2 things. Where's my nose? Okay, so this second one is to deal with single sine, single cos with even powers. We will see questions later to work on that one. And the last one is Pythagorean identity. There are 3 things we add up, like sine squared plus cos squared is 1, tan squared plus 1 is sec squared, and cos squared plus 1 is cosec squared. Okay, just asking, what's cosec squared x? what's the antidiff of that? Anyone remember? I give that on the very first page. It's minus cot. Okay, I think you just maybe remember this result. It will be easier because in the previous chapter, I provide the differentiation. D cot equals to negative cosec squared. So anti cosec squared will give you negative cot. Okay, so it's on the first page of your notes. Okay, we'll use those ones in the questions. They are like special questions. All right. Let's have a look at the first one. What we need to do is we need to extend that first. And the first two will give you 1. And that's minus a sine of 6x. Okay, use double angle formula. So remember to use double angle formula. So that's the last situation we was talking about. It's single sine, single cos times together. That's a sine 6x. So that becomes that. Okay, next one. What we should do to solve the next one? Any thinking like what we should do to solve that? What you want to substitute? If we want to substitute you, cos. Okay, so everyone, if we sub u becomes cos x in this case, we will create like when we diff it will become like we'll have a sign, right? And I can't cancel with the sign because it's not a single sign on top, it's 1 plus. Like you can't really divide them. So when you see fractions, the first thing you may think about is to separate them. Okay, I'm not going to put the 0 and powerful in, I will just separate them. So we will have that. And that. Well, I can put 0 and powerful. We'll do the substitution later. So what's 1 over cos squared? Sec squared. So what's the antidiff of sec squared? Okay. Okay, just 10. So that's sec squared. And antidiff of sec squared, it gives you 10. So the first one done, like that's 10. What we should do to solve this one? What we should do to solve that one? You can do it now. You can do substitution now. So u equals to cosine x now. And du dx equals to negative sine x. Dx equals to 1 over negative sine x of du. And then what we have now is 2 sine x of u squared times that of du. Those two get cancelled. So it's minus 2 of integral of u to the power of minus 2 of du. Minus 2 u to the power of minus 1 divided by minus 1. That's 2 over cos x plus c. We don't need the plus c here because we need to put it back to the lower limit and upper limit there, like 0 to power 4. And we can do substitutions after that. Okay. Um, I'm not going to substitute for you. You can do that by yourself later. Let's go to next page. Okay, let's do E. So we have power 3 and power 5, and we can see that's both odd powers, and we change the smaller one, okay? So we change the smaller one. So we can get one sign out, and we have like two signs left, and cosine will stay the same. And the key thing is to change. Everyone, can we stop talking, please? Sine squared becomes 1 minus cosine squared, and then we keep that cosine. So by doing that, we have keep one sign left and all the other expressions cosine. Okay, so we let u equals to cosine 3x. When we div that, we have minus 3 sine 3x. dx is 1 over that of du. So okay, that's my substitution steps. We have 1 minus u squared and u to the power 5 of the of 1 over minus 3 sine 3x of du. Okay, so simplify that. Just minus a third out, and that's u to the power 5 minus u to the power 7 of du. So that's 1 over 6 u to the power 6 minus 1 over 8 u to the power 8 plus c. If there's no value I need to substitute, you need to remember to replace that back by x. So that's minus 1 on 18. U is cosine plus 6 of 3x plus 1 on 24 cosine 8 3x plus c. Okay, just revise our substitution again. If this definite integral, there's lower and upper bound, you need to change those values as well, because that means it's in terms of x. Now you need to change it in terms of u. We will just do one more examples. I also show a special one. Like I think we find with those ones, like with one sign and many cos or many cos of many one cos or many sign. So let's do another one with even powers. These questions are the same. If you can see K or L, okay, we just do one of that. I just show you the most complex form, what it can look like. It's page 10. Okay, so if it's cosine to the power 4, it's only one cos and it's odd power. We need to think about double angle formula first. Okay, so before that, we can't really think about power of 4. So we need to think about power of 2 and then power of 2. Okay, that's the first thing we'll do. So we think every power of 2, like if it's power of 6, we know power of 2 and then power of 2 and then power of 2. That's what we'll consider about. So next thing we'll think about is cosine squared x. Like if you remember the formula, that's 1 plus cosine 2x over 2. Okay, that's the cosine squared x. If you can't remember, go back to the formula sheet. You can rearrange it together. So what I need to do after that is I need to expand it. So I have 4 here, 1 plus 2 cosine 2a, 2x, sorry, not a, that's 2x, and that's 2x. And then plus cosine squared 2x dx. Okay, the cosine squared 2x is where's the problem occurs. I can't antidiff the square one, so I need to use double angle formula again to convert that. So I will separate like that. That's 104 plus a half cosine 2x plus a quarter. Okay, now here, this one is not good. So I need to use double angle formula again to convert that. That's 1 plus cosine 4x over 2 of dx. Yeah, you just keep doing until like you have no squares. Again, until you get no squares. So you just keep doing. I don't need to use substitution in this case. So what I have is 108 plus 108 cosine 4x dx. So 104 and 108 gives you 308. So that's 308x plus a quarter sine 2x plus 134 sine 4x. Okay, so if it's power 4, you need to use the double angle formula again. Well, you can try the sine to the power 4 by itself, like it's exactly the same one. You just use the other like double angle formula to do it. What else suggest you to do? If you feel confident about all we talk about now, you don't need to do all the rest of it. You can just start with your revision. So what I suggest you to do is to think about the questions on page 11. They are a little bit special. They're not the routine ones. So think about the questions on page 11. Okay? I will go through those questions tomorrow. And the next, I think we have a double, so we'll go through partial fractions as well.